Hi, I'm Rich with insideHPC. We're here in New Orleans in SC14 and the Adaptive Computing booth. And I'm here with Brian and Paul, and they're going to show us a demo. So, hey, how you doing, guys?
Hey, we're doing pretty well.
All right, so Paul, what are you going to tell us here?
So we're going to tell you about our new elastic computing feature that's really exciting. What we're finding is a lot of customers are trying to get the benefits of elastic computing with the power of HPC. And we find that that's a winning combination, and some of the pain points we're looking to address are making sure that you don't have to give the individual contributors credit cards to just swipe on AWS. We want to have central policy control-driven use of the cloud, not randomness all over the place.
Okay, so this is all about simplicity, you're saying?
Exactly.
All right. How does it work?
So I'll let Brian take over a lot of this, but basically what we do is we integrate with OpenStack to provision resources on demand according to QoS and other attributes of the workload to make sure that we're using it according to the policy of the organization and get the work done as quickly as possible.
Okay. So what do we got going here, Brian?
Start this off. I'm going to submit some jobs into the system here, just basically fill it up. So we have a very small cluster here of just 2 nodes that are going, and the workload is already filling up those 2 nodes, so there's nothing left for the system. So basically, we set some policies in Moab to say that when the time they'll take to complete the jobs is greater than some threshold, then we're going to actually burst out to OpenStack and run some integration scripts and things to handle that. And so you can see that here. It's actually, there's a trigger that's fired, and it's bursting out to OpenStack right now. And in a second here, you're going to see those other couple nodes appear, and they'll be available for workload and be able to take on some additional capabilities of the system. And then actually, when it does burst out, it'll take a minute to get them provisioned and going. So we have a minute here waiting. Maybe we want to talk about it a little more.
Sure, absolutely. So one of the things that's really exciting about this is the opportunities that it opens up. The example that Brian's talking about is something that you might have at a small institutional, a small departmental type cluster, or maybe it's a small research group, and so they want to be able to take advantage of resources in the cloud to kind of pay as you go. One of the benefits is this is completely transparent to the end user. You just submit your jobs and this stuff happens. But what it enables is some really interesting and complex stuff like what we're doing with our professional services team for larger conglomerations of research organizations to use a shared OpenStack infrastructure to burst in and burst out as their workload changes, being able to grow and expand and incorporate additional research organizations as they get funding and they're able to buy into this common infrastructure and get the benefits of economies of scale.
Makes sense. And then, so what's the net of this? Is this something people can use today, or are you just more demonstrating a capability that has wheels?
So this is something that we're releasing with our Moab 8.1, which is coming out in December. The initial integration is with OpenStack, a little more of a private cloud model, and we're looking to add additional capability with public clouds and some of the other interesting use cases like I was describing.
Great, I really like to see, adaptive computing at the heart of HPC and the cloud, and this convergence you're describing is pretty exciting.
Absolutely.
It's a very exciting space right now. So if we want to go back to here for a second, we actually have the nodes have appeared now. See, you have the jobs are actually started running on them already. But what we're finding out is that it's actually not enough to fulfill the workload demands that we have right now. So the trigger is fired again, and it's still going out there and creating more OpenStack instances to be able to fulfill the workload based on whatever policies you have set in Moab. And that's one thing, a really important thing I'd like to point out here is that this mechanism, although very powerful, is actually based completely on what we have already today in Moab with triggers and QSs and thresholds and things. So you can utilize a lot of the power of Moab to do whatever you'd like to here. Basically, if you can imagine it, you can do it with Moab. And so we'll see this job continue running and bursting out. Once the workload is finished, there's actually a couple different things that can happen. The first thing you can do to actually release resources back into the cloud is you set a time to live on the
a time to live parameter?
Yes, for the nodes. So you say, I want you to live until this point, and after this point, I want you to go away. I want to release those resources back to the cloud or the provider or whatever it is.
And that helps ameliorate some of the spin up and tear down cost in time so that you're able to get more throughput going with the jobs.
Yes.
Kind of scary. Sounds like a James Bond thing. Time to live parameter. All right.
Yep.
So cool. All right.
So once that time to live is reached, Moab obviously won't schedule workload past that time because we don't want to have people's jobs getting killed in the middle or anything.
Yes.
So it's smart enough to handle it, and it'll actually fire off some of these node end triggers, so you can go out and delete that from whatever provider you have. In this case, it's OpenStack private cloud provider we have at Adaptive Computing headquarters. And the other way that you can actually release resources is say that you have some workload that your users say is going to take hours to run, but really only takes 10 seconds to run. You know, it's workload that they think is going to take a long time to do, but it really only takes a short time. And you end up having resources that you may be paying for out in the cloud. They're provisioned, and you don't want to pay for them the whole time. So we actually allow you through Moab to configure a node idle time, where if it's idle for a certain amount of time, it will go out and delete the nodes. So same way that it would with the time to live, but you get some configuration, some possibilities open up there through that. So in this demo cluster, we actually have it configured for about 3 minutes. And in production, you have it much longer, hours, days. But in here, we're showing that some of this workload finished really quickly, and we're going to show that that those nodes go away, while in the other workload, the time to live is reached and then nodes are deleted.